Today we're going to talk about something really cool, an AI that we're literally teaching how to see the universe. It's a new tool called AstroMorph, and it's not just about looking at pretty pictures of space. It's about learning how to spot the truly weird, the undiscovered, the needle in a haystack objects that are hiding in plain sight.
Look, our telescopes are sending back an unbelievable amount of data. We're in this amazing golden age of astronomy. But here's the catch. With this absolute flood of images, are we sure we're not missing something? Are we really seeing it all?
And that question brings us right to the heart of the problem, a problem that astronomers are actually calling a cosmic data tsunami. It's not a problem of having too little information, it's a problem of having way too much.
I mean, just think about it for a second. Telescopes like ALMA or the James Webb Space Telescope, they're building archives with millions of images. For scientists, that's a dream come true, right? But it's also a total logistical nightmare. There just aren't enough human eyes or hours in the day to go through everything.
So that's the big puzzle. How do you find that one in a million object? You know, the galaxy that looks like nothing we've ever seen, or a unique star-forming cloud that could totally rewrite our textbooks? This is exactly the kind of challenge AstroMorph was designed to tackle.
So, what's the solution? You can't just hire a million more astronomers. Instead, the team behind this took a much cleverer path. They decided to teach an AI how to see the universe for them. And that brings us to AstroMorph. Now, it's a machine learning tool, but it's got a really special trick up its sleeve. It uses something called self-supervised learning. And the key thing to know about that is that it learns to spot patterns and shapes all on its own. No human has to sit there and label thousands of pictures first.
So how in the world does it learn by itself? Well, think of it like this. Let's say you want to teach a computer what a ring is. The old way would be to show it thousands of pictures that you've labeled ring. But with this method, you just show it one ring. Then you show it a slightly rotated version, maybe a blurry version, and you just tell the AI, hey, guess what? These are all the same thing. And from that, the AI starts to figure out the essential ringness of it all. It gets the concept on its own.
The fancy name for this technique is Bootstrap Your Own Latents, or BYOL for short. And a latent is just a way of saying the essential hidden features that make a thing what it is. The whole process is kind of like a four-step dance. First, you start with one image. Second, you create two slightly different views of it. Third, an AI network creates a unique digital fingerprint for each of those views. And fourth, this is the magic part, the AI's only goal is to tweak its own brain until those two fingerprints are as close a match as possible. Do that millions of times, and it gets incredibly good at knowing what features really matter.
All right, so that's the theory. But does this thing actually work? Let's take a look at its first big test, sorting through thousands of images of protoplanetary disks, which are basically cosmic nurseries where new solar systems are born. And the result is honestly beautiful. AstroMorph took all these images of disks from the ALMA telescope and created this map, completely on its own. Now, this isn't a map of where things are in space. It's a map of shapes. Every dot is an image, and the AI has clustered them together into these little islands based on what they look like. So if two objects have a similar shape, they end up as neighbors on the map. And this is where the tool becomes a total game changer for scientists. Let's say an astronomer is really interested in a specific rare object like this one. It's called GG Tau, and it has these amazing rings. The big question is, can they use AstroMorph to find more like it, hidden somewhere in that massive archive? And the answer is a huge yes. You can see it right here. On the left, that's our target, GG Tau, and on the right, those are the top matches AstroMorph found across the entire dataset, all based on that digital fingerprint it created. It's like a cosmic search engine, but for shapes. It instantly pulls up other ring-like structures for scientists to dig into.
Okay, so it proved it can find similar-looking things. That's cool. But the next test was even tougher. Instead of these relatively neat disks, they tasked the AI with analyzing the big, messy, sprawling shapes of molecular clouds.
And what it produced was totally different. Remember those separate little islands we saw with the disks? Well, for the molecular clouds, AstroMorph created this continuous, flowing river of shapes. And that suggests something really profound. It suggests that maybe these clouds don't fit into neat little boxes or categories, but instead represent a gradual evolution. They're slowly changing their shape over cosmic time.
So the researchers had to dig a little deeper. They ran an analysis to figure out what was the AI even sorting by. And the results were just stunning. Without anyone telling it to, the AI had learned to organize these clouds by their actual physical properties. Along one axis, it sorted them by size, from small to big. And along the other axis, it sorted them by how concentrated or dense they were. It didn't just learn to see shapes, it learned to see the underlying physics.
When you put all this together, these results are really pointing towards a massive shift in how we even do astronomy. This could be the beginning of a new age of discovery, where AI becomes this essential partner in how we explore the universe.
And the potential here is just enormous. The team is already getting AstroMorph ready to sift through data from the Webb telescope and the upcoming Square Kilometre Array. It could even be used to analyze 3D data, which would capture not just shape, but motion and velocity too. And get this, the core idea is so flexible, it's already been used completely outside of astronomy to analyze ship movements.
And that just leaves us with this one final, really mind-bending thought. For centuries, scientific discovery was limited by what a human being could literally see with their own eyes through a telescope. Now, we have an AI that can see for us, that can sort through millions of cosmic objects and pick out the things that are truly strange and new. The only question left is, what unknown wonders will it discover next?